Hey guys, so today we are continuing to graph our exponential functions. So we started with our exponential functions and their key attributes, so we're going to continue with that today. So our exponentials have the parent function of y equals b to the power of x, where b cannot be 1. It's going to be any number other than 1. Then we have transformations that can occur, just like any other function. And they occur in the form a, b, x minus h plus k. So if we have an a greater than 1, then that means we have a vertical stretch. If we have an a less than 1, so a fraction, we have a vertical shrink. If we have a negative a, then that is a reflection across the x-axis. That minus h is going to be our horizontal shifts. And as always, our horizontal shifts are going to take us the opposite direction because of that minus in there. So if it says minus 2, then we're moving to the right. So think opposite. And then our k is going to be our vertical shifts up and down. And we take those as is. We don't change them, we don't take the opposite, anything like that. So those are the transformations that we can have on our exponential functions. So we'll get started with each of these. It does say sketch the graph. We're not really going to sketch them on a graph, like a piece of graph paper, as you can see. So whenever we have these functions, my parent function is whatever is being raised. So 1/2 to the x is my parent function. So remember, if it is a fraction, that means we've got decay. If it is a whole number, we've got growth. So decay looks like that, growth looks like that. So I have this 1/2 x blah blah blah. My parent function is decaying, so it looks like this. My new function with the transformations on it is flipped because of this negative here. So flipping that over the x-axis, my new function will look like this. So the parent function has an asymptote at y equals 0. And we have this transformation of +1, which means we're moving the graph up 1. So my new asymptote will be at y equals 1. The domain is going to be all real numbers because I see that my arrows are headed in the left and right direction forever and ever and ever. So yes, it will take a long time, especially here on the left side, to get through all of those x values, but we are moving a little bit at a time and we are going to get there. For the range, my asymptote is here at y equals 1, and we're getting lower and lower and lower and lower. So my range is everything less than 1, not including 1. And then in order to find the y-intercept, we need to plug in a 0 for x. So that's -3 times 1/2 squared plus 1, which is -3 times 1/4 plus 1, which is -3/4 plus 1, which is 1/4. So our y-intercept occurs as 0, 1/4. And then we've got everything else filled in there. Now in number 2, we're going to do the same thing. So we're going to go step by step. The parent function on number 2 is y equals 2 to the x, which is an exponential growth. So my parent function looks something like that, with y equals 0 as my asymptote. The asymptote is moving down 2, so y equals -2 is now my asymptote. I do have a reflection because it is -1/2, so my new function will look like that, with the asymptote moved to y equals -2. So that changes my range to be everything less than -2. The domain, we're going to hit every single x value eventually. And then the y-intercept. We're going to plug in a 0. -1/2 times, this would be 2 to the -2, which is 1/4 minus 2. -1/2 times 1/4 is -1/8. -1/8 minus 2 is -17/8. On number 3, our parent function is y equals whatever's being raised, so 2 to the x. So that is a growth. My new function has a negative in front, so it is reflected, which means it looks like that. And the asymptote has moved from 0 up 1, so that's y equals 1. And the reason we focus on the up and down movement for the asymptote is because the asymptote is a straight left to right line. If I move it 2 units left, it doesn't matter because it is still going on forever and ever left and right. So that's why we focus on that up-down movement. Domain is still going to be all real numbers. Our range depends on the asymptote. Since we're facing down this time, we're going to be everything less than 1. And then our y-intercept. Replace x with a 0. And -5 times 4 plus 1. -20 plus 1, which is -19. So our y-intercept is at 0, -19. And number 4, parent function, whatever's being raised to the x. So we have 1/2 x, which is a decay, so it would look like that. Our function is reflected, so ours looks like that. And our asymptote is moved up 1, so this is y equals 1. Our domain, we're facing down again, so everything less than 1. Range is all real numbers. I'm sorry, domain is all real numbers. And then finding our y-intercept, plugging in a 0 for x. 1/2 to the negative 2 power is 4. Negative 20 plus 1, again, is negative 19. So these functions had the same transformations on them for the stretch and for the up-down movement, but one of them will be shifted to the left, one of them is shifted to the right, and one was originally a growth and one was originally a decay. Number 5, parent function, is y equals 3 to the x. 3 is a whole number, so this was a growth. Our function does not have a negative in front, so it still is a growth, and it's moved up 1, so this asymptote, up 2, so that's y equals 2. And it is facing upwards, so my range is everything greater than 2. Domain is all real numbers, and that y-intercept we'll find by plugging in a 0 where we see x. And we get 8, so 0, 8 is our y-intercept. Number 6, my parent function is y equals 3 to the x, which again is a growth. And we don't have a negative in front, so our function will still be a growth. But we do move that asymptote up 2. We're going to be everything greater than 2. We're going to find that y-intercept. One half times 9 plus 2. 9 over 2 plus 2, which is 13 over 2. Number 7, parent function, y equals 2 to the x. So 2 to the x would be a growth, but my function is reflected. So my function will look like that. And we've moved the asymptote up 1. So then my values will be everything less than that for the range. Domain is all real numbers. And y-intercept. We'll plug in a 0. Negative 7. So 0, negative 7 for our y-intercept. Number 8, parent function, y equals 2 to the x. We find that just by taking whatever is being raised. So like here, it'd be 1/2 to the x. And so if it's a whole number, it's growth. I have a negative in the front, So my function will be reflected, and my asymptote will move down 2. So y equals -2 is my asymptote. I'm facing down, so everything below -2 is in my range. Domain is all real numbers. And my y-intercept. -1/8 minus 2, which is -17/8. Number 9. Parent function, whatever is being raised, so 1/2 to the x. 1/2 is a fraction, so we have decay. But our function is reflected because of this negative here. So our function will look like that. And it has +1, so the asymptote is not at 0, it's at 1. So we're including everything less than 1 in our range. And -1/12 plus 1, which is 11/12. And then on number 10, parent function, I've already circled it, 1/2 to the x. Parent function is decay. Our function is reflected, so it looks like that, and it's been moved up 2. So our asymptote will move up 2 as well. Our range is going to be everything less than that. Domain is all real numbers. And the y-intercept we'll find by plugging in 0 for x. So -2 times 1/2 plus 2 is -1 plus 2, which is 1. So our y-intercept occurs at 0, +1. So then that's 1 through 10, and then you all will do 11 through 20 for your homework. I need to see a sketch of what direction our graph is going toward. I don't need a perfect sketch. I don't need to know any points, but I just need to know, are you facing this way? Are you facing this way? Are you facing this way? Or are you facing this way? That's what I need to see. So what direction are you facing? And then I need you to fill in all the other information. And I especially need to see your work for the y-intercept. So you just got 10 problems to do. And it should look like mine when you're done. So then when you finish all 10 of those, turn those in on Canvas, and then I will see you guys in the next one.